So for the basic question, it says the drug AZT was the first drug that seemed effective in delaying the onset of AIDS. Evidence for AZT's effectiveness came from a large randomized comparative experiment. The subjects were 1,300 volunteers who were infected with HIV, the virus that causes AIDS, but did not yet have AIDS. The study assigned 435 of the subjects at random to take 500 milligrams of AZT each day, and another 435 to take a placebo. The others were assigned to a third treatment, a higher dose of AZT. We will only compare two groups. At the end of the study, 38 placebo subjects and 17 of the AZT subjects had developed AIDS. We want to test the claim that taking AZT lowers the proportion of infected people who will develop AIDS in a given period of time. So A wants us to state the hypotheses and check that you can safely use the Z procedure. So here I have P1 as the proportion of patients with HIV who developed AIDS while taking AZT, and P2 is the proportion of patients with HIV who developed AIDS while taking a placebo. So our HO is P1 is equal to P2, and our HA is P1 is less than P2. For our assumptions, we can assume randomness as stated in the problem, and here we have how N1 and P1 and N1 and Q1 are greater than 10, and N2 and P2 and N2 and Q2 are both greater than 10 as well. And it's a 10 n sample size, which is less than the population. B asks, how significant is the evidence that AZT is effective? So we're going to be doing a two-proportion Z test. So our P1 is 0.03908, and our P2 is 0.08736. To get those numbers, we just took the subjects that developed AIDS with each of our placebo and the AZT and divided it by the 435 to get those answers. So the formula for a two-proportion Z test is Z equals P1 minus P2 all over the square root of P1 and Q1 divided by N1 plus P2 and Q2 divided by N2. So when you plug that all in, this is what you get. 0.03908 minus 0.08736 all over the square root of 0.03908 times 0.96092 divided by 435 plus 0.08736 times 0.91264 divided by 435. And the Z that you get is negative 2.9403. And our p-value, after looking at our Z-score chart, would be 0.0017. So using an alpha value of 0.05, we reject the HO based on our p-value of 0.0017, which is less than our alpha of 0.05. C says, the experiment was double-blind. Explain what this means. So for this experiment to be double-blind, it would mean that the subjects don't know which drug they are taking and the people administering the drugs don't know which drug they are giving. And that's all for the basic question.